Alright, hello and welcome to another physics tutorial. So today we will be covering problem number 54 in chapter 13 about gravitation. So, in our problem, we have a two-star system which rotates about their common center of mass. We know the mass of the first star, and we want to find the mass of the second star. Alright. So, let's set up a few equations. So first we can say that the gravitational force, if this total distance is r, we can say that our total gravitational force is g m1 m2 over r squared. That's in the wrong place. R squared. We can also say that our gravitational force is a centripetal force, which means that it equals m1 v1 squared over r1. Alright. Furthermore, we can say that r equals r1 plus r2, and also that period equals 2 pi r over v. So let's work with our equations. Oh, right, and center of mass means that m1 r1 equals m2 r2. So let's substitute so let's find r2 with this center of mass equation. So we get that r2 equals m1 r1 over m2, which means that we can plug that in to r equals r1 plus r2 to find that r equals r1 plus m1 r1 over m2, which, if you come denominator, means m1 plus m2 times r1 over m2 is r. Alright. So we can also take our period equation to find this is r1, I guess, r1 v1. So we have r1 equals tv1 over 2 pi, gives us another equation for r1. So we can plug that into our previous equation for r to get that r equals m1 plus m2 over m2 times tv1 over 2 pi. Alright, so what we then do is plug this equation for r into our equation for gravitational force, giving F equals g m1 m2 over m1 plus m2 over m2 tv1 over 2 pi squared, which then simplifies down to 4 pi squared g m1 m2 cubed all over m1 plus m2 squared times v1 squared t squared. Alright, so we got this value for r1 earlier, which we can plug into our centripetal equation to get that F also equals m1 v1 squared over tv1 over 2 pi, which equals 2 pi m1 v1 m1 over t. So now we can set these two different expressions for force equal. So we have 4 pi squared g m1 m2 cubed over m1 plus m2 squared v1 squared t squared, which equals 2 pi m1 v1 over t. So we can cancel a 2 pi, we can cancel, no, that's the wrong, wait, yes, that is the right one. So we do that. So next what we can do is to simplify this into, so we do that. So this simplified expression ends up being v1 equals 2 pi g m1 cubed over m1 plus m2 squared v1 squared over t. So we can rewrite this as t. Oh wait, this is m2, right? So then what we can do is just isolate m2 to get m2 cubed over m1 plus m2 squared equals v1 cubed t over 2 pi g. Now, we know all of these values, so we have v1 cubed t over 2 pi g, which equals 6.9 times 10 to the 30 kilograms. Now, because we know m1, we can now solve for m2. So if you do all of that algebra, because I'm running out of room, we should find that m2 equals 9.3 times ms. Alright. Thank you for watching. I hope you learned something about two-star systems. The algebra is definitely very long, but once you get the hang of it, it's not that bad. Alright. Please like the video, subscribe to the channel, and I will see you later. Bye!